Today we are discussing exponential and logarithmic functions. This is section 8.1 and 8.2 in the Algebra 2 book. An exponential function can be represented by either exponential growth or exponential decay. The graph of an exponential growth slides up to the right and is flat on the left, and exponential decay slides up on the left and is flat on the right. For an exponential growth equation, an example would be y equals 3 to the power x, or y equals 2 to the power of x, or y equals 4 to the power of x. Your base number has to be bigger than 1. For exponential decay, your base number has to be a fraction smaller than 1. So like 1/2 to the power of x is an example of exponential decay, or 1/3 to the power of x, or 1/4 to the power of x. Any fraction that's smaller than 1 would represent exponential decay. Notice that in either growth or decay, the x is in the exponent of the equation. An example of an exponential growth function is the story that we read, 1 grain of rice, where they started with 1 grain of rice on the first day, and every day they doubled the amount of rice from the day before. That's growing, so that's exponential growth. In the NCAA tournament in March, this is an example of exponential decay. We start with 64 teams, 32 advance, and then 16 advance, and then 8 advance, and so on until you have the championship. So that's exponential decay. Anytime you have a relationship where something is multiplying or dividing every time, that's exponential growth or decay. Alright, in these next 3 examples, we're going to be solving for x each time. And notice that on each side of the equation you have a base number that is the same. So what we do is we start by canceling out the base number that is the same. In example 1, the base is 3 on each side of the equation. We cancel that out and we get that x is equal to 4. On example 2, the base number is 9 on both sides of the equation. We cancel that out and we have the equation 2x equals 3x minus 1. To solve for x, we're going to subtract the 3x to the left, making negative 1x equals negative 1, and divide negative 1 to the right, so we get x equals positive 1 for our final answer. Try example 3 and see if you can work this out. Okay, cancel your bases of 2's, and we have the equation 4x equals x minus 3. Subtract the x to the left side to get 3x equals negative 3, and now divide by 3 to get x equals negative 1. Now we're going to practice writing exponential equations in their logarithmic form. A log function is the way to rewrite an exponential function so that you could solve the equation if you needed to. For example, on number 1, when we have 3 to the power of x equals 81, our base is 3. So to rewrite this in log form, I would say log base 3 of 81 equals x. Identify your base first, and when you write the word log, you put the base number as a subscript, and then you switch the places of the x and of the 81. So the 81 comes over close to the 3 and the x moves away from the 3. On example 2, our base number is a 2, so to write this in log form, I would say log with a base of 2, that's going to be the subscript. Bring the 1 over 16 next, and then move the x away to the other side of the equal sign. So this is how it looks. Log with a base of 2 of 1 over 16 equals x. On the third example, our base number is 5, so I'm going to say log with a base of 5 of square root 5, and it equals x. Once you identify your base, write that as a subscript for the log, bring the square root of 5 over to the left side of the equation, and move the x to the right side of the equation. So identify your base, and then switch the places of the other numbers. That's how you rewrite something as a log. Logs are good because they can be evaluated in our calculator, and if I didn't know 3 to what power was 81, I could use my calculator to evaluate that logarithm and I could figure out what it was. Okay, take a little bit of practice time and rewrite each one of these problems on the left side of the screen into log form. Pause until you're ready to go over them. Alright, on number 1, your base is a 2, so we're going to say log base 2, then 64, and it equals 6. Here's how it's read. Log base 2 of 64 equals 6. On number 2, the log base is 4, so we say log base 4 of 64 equals 3. On number 3, the base for the logarithm is 3, so we're going to say log base 3 of 1/9 equals -2. Every time you write something as a log, identify your base number, that gets written as the subscript, switch the places of the other two numbers in the problem. Now we're going to go to the right side of the screen and we're going to practice writing something in its exponential form. This is taking away the word log and writing it back as an exponential. I'll do one with you for an example. On number 1, your base number is a 5, so I would say 5 to the power of 4 equals 625. Your base is 5. Now I switch the places of the 4 and the 625. So the 4 comes to the left side of the equation, the 625 goes to the right side of the equation. Look at the next two and see if you can do them without my help. On number 2, the base is 10, so we're going to say 10 to the power of 2 equals 100. And then on number 3, your base is a 2, so you're going to say 2 to the power of 1/3 equals cube root 2. Alright, now we're going to learn how to evaluate a logarithm. This is why we practice learning how to write logarithms, is because you can actually evaluate them for what they are, and it's a handy little tool to use. When you're evaluating a logarithm, like number 1 where it says log base 5 of 1 over 125, you type the log into your calculator. We take the bigger number, not the base number, but the thing that we're taking the log of. Here it's 1 over 125, and that gets typed in next. And then we divide by log of our base number. So log of 1 over 125, close parentheses, divided by log 5. Your base number always goes on the bottom of the fraction. Base starts with B, bottom of the fraction starts with B. So base on the bottom. Now when you type this in your calculator, you get an answer of -3, and that is the answer to this logarithm. On number 2, log of 1/8, close parentheses, divided by log of 1/4, close parentheses. The base number is 1/4, that's going to go on the bottom of the fraction. 1.5 is our answer. On number 3, log of 5 to the power 4, close parentheses, divided by log of 5, close parentheses. The base number was 5, so 5 should go on the bottom of our fraction. This one equals 4. This is how you evaluate a logarithm in your calculator. Now we're going to practice rewriting these in log form so that we can evaluate them and solve for x. Look at the first one. Right now it reads 2 to the power of x equals 64. Now you might know what power of 2 is equal to 64, but if you don't, here's how you can use logs to figure it out. Think about what your base number is for this problem so that when we rewrite it as a log, you can write your base. The base here is a 2, so we would say log base 2, then we're going to say 64, and it equals x. Now we want to evaluate this in our calculator. The base number is going to go on the bottom of the fraction, and we type this in as log of 64, close parentheses, divided by log of 2, close parentheses. When you evaluate this in your calculator, we get an answer of 6, so that's the answer to the problem, x equals 6. Try the next one. Rewrite this as a log, and then type it in your calculator so you can find the answer. Your base number is 3, so we're going to say log base 3 of 1/9 equals x. To type this in our calculator, we do log of 1/9, close parentheses, divided by log 3, close parentheses. The base is 3, so make sure you have that on the bottom of the fraction. When we get done evaluating, we get -2, so x equals -2 is our final answer. On the last one on this slide, the base is 5, so log base 5 of 125 equals x. To type this in our calculator, we do log of 125, close parentheses, divided by log 5, close parentheses. 5 was the base, it goes on the bottom of the fraction. 3 is what we get, that's our final answer. 3 equals x. On these last 4 problems, we're going to rewrite them in their exponential form, taking away the log and solving for x. On number 1, we want to take away the word log, and to do that you have to identify what your base is. Your base for number 1 is a 2, so we're going to say 2 to the power of 4, and it equals 2 to the power of 3x plus 2. Once you identify your base was 2, the 4 comes to the left side of the equation, everything else goes to the right side of the equation. Now you have a base of 2 on both sides of the equation. We're going to cancel that out. And now we have the equation 4 equals 3x plus 2. Subtract 2 to the left, giving you 2 equals 3x. Divide by 3. 2/3 equals x is our final answer. Try number 2. Rewrite this without the word log, and then cancel your bases so you can solve for x. Alright, rewriting this without a log, your base is 7. So we're going to say 7 to the power of 2x minus 20 equals 7 to the power of 6x. Once you identify your base as 7, the 2x minus 20 comes to the left side of the equation. Everything else, or 7 to the power of 6x, goes to the right side of the equation. Cancel your bases of 7, they're both the same, they cancel out. And we have the equation 2x minus 20 equals 6x. We're going to solve this. Subtract 2x to the right side, giving you 4x. And now divide by 4, so negative 5 is our final answer. On number 3, your base is 2. To rewrite this, we say 2 to the power of 3 equals x. And now we evaluate 2 to the power of 3, which is 8. So 8 equals x. On number 4, last one, your base is x to the power of 2 equals 16. What number squared is 16? If you know that, then you're good to go. If not, you have to square root 16 in your calculator. X equals 4. Final answer.